All right, so let's look at this one. So here we have, again, following graph theory, analyze this function and state all the pertinent information. All right, so what values can we put into this equation and work for the domain? Well, the domain, that's going to be basically everything we put in there should work, okay? So that's going to be okay. Now, let's think about what we have here. So if we want to first set this equal to 0, if we have 3x to the 2/3 minus x equals 0. Now, the way to I'm thinking about this is I want to get this to be a 1. And so if I can factor out an x, then when I set this whole thing equal to 1, whatever's in my parentheses, I'll take it over and it'll be a lot easier to solve. So if I pull out an x here, what does that give me? That gives me a 3x to the what? -1/3 minus 1 equals 0. Then I have x is equal to 0 from this. And then I have a 3. Now, x to the -1/3 is going to be the basically, x to the 1/3, and then minus 1 equals 0. Take that over, and then I have 3 over x to the 1/3 equals 1. Multiply that by the x to the 1/3. That cancels on both sides. And now basically I have 3 equals x to the 1/3. If I want to solve for x here, what do I have to do? Well, I have to cube both sides. So 3 cubed equals x to the 1/3 cubed. And so x is equal to what? 27. Okay. So that would give me this. And so then I would have 0, 0, and I would have 27, 0. So those are 2 points where I'm going to cross the x-axis, or at least get to the x-axis. Okay. Now, the next things I need to do is I need to think about taking derivatives. All right, so first derivative. Well, if I bring down a 2/3, 2/3 times 3 is going to give me 2. So that's going to be 2x. 2/3 minus that's going to be -1/3. And then that's going to be a -1. Now, my second derivative, well, I bring down to -1/3, so that's going to be a -2/3 x to the what? Well, subtract 1 from that, it's going to be a -4/3. Well, the derivative of that's gone, so I don't have to worry about it. Now, setting these equal to 0, well, this one, if I do that, that's again 2 over x to the 1/3, and then -1. And if I set that equal to 0, well, here I have to think about a couple things. First off, x cannot be equal to 0, right? So x cannot equal 0 because then it's going to be a failure. So that's going to be kind of a key thing. So I can't have 0 here. So that's going to be where, I have that, remember the ND? Okay, so that's going to be one of those ND parts. Now, if I solve this and pull the 1 over here, then I'll end up with 2 equals x to the 1/3, because I'm going to take the 1 over, it becomes a 1, multiply by x to the 1/3, so I'll have 2 equals x to the 1/3, and then I'm going to do the same thing I did over here. I'm going to cube both of those, and then I'll have x is equal to what? 8. Now this is going to be a 0 because it can work. It'll be okay, but I can't have the x equals 0 here because of the fact that I can't have this divide by 0. Now, when I do this one, basically, if I set that equal to 0, then x is equal to 0. Okay, so now I've got one place I can do this sign chart, and then the other piece I'll have this sign chart. All right, so if I do this sign chart up here, I've got the 8, and I've got the 0. And so then that's going to be, I can look at a 9, I can look at maybe a 7, and I can look at, say, a -1. Now remember, this is ND, this is 0. And so the ND means I can't have a derivative at that point. So it's going to be probably a sharp point or something like that. All right, so if I plug in a -1, what's going to happen is I'm going to get negatives here. Okay. Now, from here up until 0, I'm going to get positives. Okay. And after that, I'm going to get from 8 on up, I'm going to get negatives again. So I'm going to have decreasing here, I'm going to have increasing here, and I'm going to have decreasing here. Now, again, this going from here to here, that's kind of a key piece where there's a change from positive to negative or negative to positive, however you want to look at it. But because it's not changing, there's going to be a no derivative at that point. We have to think about that one separately compared to this one here. This one is we're going to have a change, and it's going from a positive to a negative. And so this is going to give me uh, local max. But this one's going to be, something kind of funky here. So we're going to leave it as that for now. Now this one, what do we have here? Well, we have a 0, we have a -1, we have a 1. We start plugging in our values. Again, this was our f prime. This is going to be f double primes. And if we plug in these values, what do we get? Well, on this one, for f double prime, they're going to be negatives. Well, it's also going to be negatives over here. So there's going to be no change. And so there's no inflection point. Okay, so that's going to be kind of what we see at this point in time. All right, so with all of those pieces, let's see if we can try and draw a graph. Again, graphing is not my expertise as far as hand drawing, but we'll see what we can get. We know 0, 0, and 27, 0 are points where it's going to be a point on the graph here. Then at 8, we're going to have what? We're going to have some kind of a local max. So it's going to be, maybe, I don't know where it's at, up here. Okay. Again, we're just getting a rough graph of things. And now, what else do we know? We're decreasing here, increasing, decreasing. And so kind of, we're kind of, it looks like we probably do something like that. Now, the key thing is we need to think about how it's going to be. It's going to be concave down here. It's going to be concave down here. So all the places it's going to be concave down, no matter if we're on the left side of 0 or the right side of 0. So basically, we're going to have something like that on this side. It's just going to be concave down, and it's not changing anything. It's just going to be concave down. Now here, we're increasing, and again, it's going to be concave down. So again, we're just going to be doing something like that. And at that point, we're going to be not doing very good, but hey, at least we hit the point there. It's going to be concave down. This is going to be our horizontal. And at that point, 8, because we know we're switching from increasing to decreasing for our slope graph. And then at that point, we're going to be at going through that because of this here point. We're hitting 27, 0. We're going to go through. And at this point, this is the no derivative. And that's because we have that sharp point. So we're coming in here, hitting that, and then we're bouncing back up, and then we're coming back down. Okay. So I've plotted this on the calculator. I think I have it anyway. And that's going to be what it looks like. We have, again, our 3x to the 2/3 minus x, and it's coming down, concave down. Then we're coming up, and we're going back down, and that's about the 27, 0. We have our 8, 0 or 8, whatever it is. It's going to be the point where we're crossing over. We're going from concave down to concave down, but we have a max point at that 8, 0. And so that's going to be kind of what it looks like. Okay, again, rough graph here, but that's kind of how this works and all the different pieces that you need to get to the point where you can actually draw this graph using first, second derivatives and that 0, and knowing that your domain is all the whole number line. All right, so let's stop there and come back for more.